All right, let's jump right into this explainer. Today, we're unpacking a really weird anomaly floating out there in the main asteroid belt, right between Mars and Jupiter. We're talking about the strange, tumbling mystery of asteroid Donaldjohanson. Back on April 20th, 2025, NASA's Lucy spacecraft did a flyby of this tiny space rock, buzzing it at just about 6,000 miles away. Honestly, astronomers thought they were just checking a box, getting some routine calibration imaging done. But as we're going to see, the data that got beamed back to Earth, it revealed a complete cosmic puzzle that literally no one saw coming. See, in the vast vacuum of space, researchers fully expected this little asteroid to move in a totally predictable, steady pattern as it orbited the sun. I mean, that's just standard behavior, right? But reality completely defied those expectations. The Lucy spacecraft captured a rock that isn't just wobbling, it's actively wobbling in two completely different directions at once. It's basically tumbling through space. And to really grasp why this is just so bizarre, we kind of need to understand what exactly it is we're looking at. First off, the scale of this thing. Donaldjohanson is tiny. We're talking just 800 meters across, so roughly half a mile. Out there in the grand, sweeping scale of the solar system, it's practically a speck of dust. Finding and tracking something this small from Earth is incredibly tough, which is exactly why managing to send a spacecraft to literally fly right past it is such a huge deal. And when Lucy finally got close enough to snap some clear pictures of this 800-meter rock, it confirms something astronomers had really only been able to guess at using ground-based telescopes. It all comes down to its shape. Science has a very specific term for this, an elongated contact binary. Now, what does that actually mean? Well, it's basically an object that forms when two smaller bodies collide in space, but instead of shattering into a million pieces, they just sort of smush and stick together. You end up with these two large lobes connected by a much narrower little neck. Telescopes back on Earth had hinted that Donaldjohanson might be kind of oblong, but that flyby provided the absolute undeniable proof of this weird two-lobed structure. But honestly, we can translate all that complex science jargon into a visual that makes perfect sense. It's a tumbling cosmic peanut. Seriously, that is exactly what this asteroid looks like. Just picture a giant peanut shell, with the two distinct bumps and that pinched middle, just endlessly cartwheeling through the pitch black of the asteroid belt. It's such a great visual, and keeping this giant peanut in mind is super important as we break down the weird physics of how this rock is actually moving. Okay, so let's decode that movement, starting with the first axis of its wobble. According to data published in the journal Science back in June 2026 by the team at the Southwest Research Institute, this asteroid rotates end over end once every 10.5 Earth days. So just imagine our cosmic peanut slowly flipping head over heels. Now, that alone is pretty cool, but it's the combination of movements that really threw the researchers for a loop when they looked at the flyby data. Because the picture gets even stranger. While it's doing those end-over-end flips every 10.5 days, it is simultaneously wobbling along its horizontal axis every 26.5 Earth days. So it's flipping and spinning at two completely different, totally unaligned rates. It's messy. This chaotic tumbling is exactly what caught the astronomy world off guard. But the crazy physics of its movement? Yeah, that was just the first surprise Lucy uncovered. Section 1. A watery past tracing the clay minerals. So the really crucial thing here is we have to look past the weird shape and the tumbling and actually look at what's on the surface of this rock. Because as it turns out, Donaldjohanson holds clues to a history that is vastly different from its current dry, freezing state. Lucy's instruments actually detected an abundance of clay minerals right on the surface. And here's the kicker. Clay minerals absolutely require liquid water to form. You literally do not get clay without a wet environment. When scientists compared this data to known carbon-rich meteorites that have fallen right here to Earth, like the QE97990 meteorite, the chemical makeup was strikingly similar, which definitively proves that this little tumbling peanut was, at some point deep in its past, exposed to actual liquid water. No way around it. But wait, how exactly does a tiny rock tumbling through the freezing vacuum of space get exposed to liquid water? Well, scientists believe Donaldjohanson wasn't always a peanut. It actually formed from the shattered fragments of a much, much larger parent asteroid. And that massive parent body, it was loaded with water and carbon. But for our little peanut, that watery phase ended way too early. The data tells us it just didn't have enough sustained heat or honestly enough total water to keep forming those clay minerals over a longer period. Let's pull all this together onto a timeline, just to really grasp the sheer scale of this story. We start around 155 million years ago. A massive parent asteroid breaks apart, and those fragments eventually smush together to form our tumbling peanut. Fast forward millions of years, back to Earth in 1974. Paleoanthropologist Donaldjohanson makes a massive discovery, the famous early human fossil nicknamed Lucy. Then, jump to April 2025. A spacecraft named Lucy flies past an asteroid named after the exact scientist who found the fossil. And finally, looking ahead to August 2027, that very same spacecraft is expected to reach its ultimate destination, the Jupiter Trojan asteroid Eurybates. There's just something incredibly human about how we explore the stars. It's this beautiful, almost poetic connection. We've got a spacecraft named for a monumental human ancestor fossil, flying millions of miles through the dark to visit an asteroid named for the guy who pulled that fossil out of the dirt. It's a great reminder that behind all the intense orbital mechanics and deep space chemistry, it's just pure human curiosity driving the whole shebang.
Section 2. Next stop, Jupiter's Trojans, the ultimate mission. And that brings us to the much grander context of this entire mission. Because as amazing as our tumbling peanut is, Donaldjohanson wasn't actually the main target. It was really just the appetizer. The strategic sequence here is key. This flyby was fundamentally a practice run. NASA needed an object in the main asteroid belt to test out Lucy's cameras and tracking procedures before the real show began. After acing that test, the spacecraft is now continuing its massive journey out to Jupiter's orbit. The ultimate goal, step 3, exploring the Greek and Trojan asteroid swarms, these two massive clusters of space rocks that lead and trail Jupiter as it orbits the sun.
So why go all that way? Well, Simone Marchi, the deputy principal investigator of the Lucy mission and the lead author of the study on our peanut asteroid, sums it up perfectly. He points out that the Jupiter Trojans are a completely different population of space rocks. They have totally different histories compared to what we see in the main belt. Marchi notes that once we actually start getting data back from these swarms, our entire understanding of how the solar system formed is likely to be completely challenged. It's going to be a real game changer. Which leaves us with a truly thrilling thought to wrap up today's explainer. If a simple, routine practice run past a tiny half-mile rock revealed a tumbling cosmic peanut with a hidden watery past, what massive paradigm-shifting secrets are just waiting for us out there in the shadows of Jupiter's Trojans? The Lucy mission is really just getting started, and we are going to be eagerly waiting for that August 2027 arrival to find out. Thanks so much for joining me to unpack all this amazing data. Keep learning, and I'll catch you in the next explainer.